Hello everyone. LOD, which is level of detail expressions, are a very powerful concept in Tableau. And it would not be surprising to see people who have spent many years working on Tableau who have not worked with level of detail. Level of detail was introduced many years back, but there is still a lot of confusion about what is the use case and how do we work with it. Another very common question that people have is it only meant for complex calculations or can it also be used for very specific business use cases that might not be very complex in nature, but that might not be possible using traditional methods of data visualization? Now, this course is meant for people who already are aware of the basic fundamentals of Tableau, which is how to create a calculated field, how to use parameters, how to create different types of visualizations. Now, Tableau is very powerful when it comes to computing values at both the data source level and the visualization level. But level of detail will give you even more control on the level of granularity that you want to compute. And there are three different ways we can do this: include, exclude, and fixed. Now, I know that simply by reading this slide, it doesn't seem very clear as to what it does. So let me quickly hop over to a data set and we will create a problem statement. Here we have a data set, which is the Superstore data. The file has been given in the resources. We have the order date, shipping mode, customer ID, customer name, segment, country, city, state, postal code, region, product ID, category, subcategory, product name, sales quantity, discount, and profit. So broadly, this is a data set for a company that is selling multiple products in multiple regions in the United States. So we have the data for 4 years, which is 14, 15, 16, and 17. There are 4 shipping modes. There are over 700 unique customers that we have. 3 business segments, cities, 49 states, 4 regions, Central, East, South, and West, 3 categories, furniture, office supplies, and technology, and 17 subcategories. We also have the sales quantity, discount, and the profit amount. Let's make a pivot table. If we keep our customer name in rows and we keep our sales value in values and we finally keep our region in filters. If we want to find the average of all the transactions for each single customer, you would see that the average for Aaron Bergman is 147, Aaron Hawkins is 158, Aaron Smelling is 305. And the overall average for the company is 229. If we go through it region by region, Central is 215, East is 238, and so on and so forth. Let's do the same thing on Tableau as well. All right, so we'll connect to our data set. Select the orders table. And what we want is we want to find out the average of each transaction for each of the 4 regions that we have. To do this, we can put region in columns. We can put sales in rows. Let us also put sales in the label. And we then want to convert the sales aggregation into an average. And the label also becomes an average. As you can see, 215, 238, 241, 226. That is exactly what we found out here. Just to show you that the results are correct, if I keep the region here, 215, 238, 241, 226, and 229, the same numbers. What we want to find out is not the average for every transaction, but we want to find the average of the customers. That means if I look at the total, which is the sum, Aaron Bergman has done 886, Aaron Hawkins has done 1744. So basically, if we look at all of these numbers for every single customer, then the average comes to 2896, what you can see at the bottom. And if we go through it region by region, Central average will come as 796, East will come as 1007. What do these numbers signify? For example, Central is coming as 796. Let me just write that down. Right? And if we change it to an average, then the average comes as 260. The 216 means that it's the average of each and every transaction for all customers, while 796 is the average of customer total. That means if I look at the total of each customer and then I average all these totals, then the number will come to 796. This is what we want to create. So we want to create a LOD expression. Let us come to Tableau. We will click on Analysis. Please click on Calculated Field. And let's call this Customer Total Average. We put two curly braces, and inside this we would write include, and we want to include the customer name, and then we want to find the sum of sales. So let's understand what is happening. We are finding the sum of sales at the level of each customer. That means it will find out the sum of sales for Aaron, which is 576, Aaron Smaling, which is 1476, Adrian is 12181, Alan is 37. So like this, for each and every single customer, it will find the total sales amount. So basically, it is creating an invisible column in which the total of each customer is there, and then we can average them out. So I'll go to press OK. Now once we have done this, you would notice that we get a new calculated field here. Let's put this inside our rows, and from the second marks card that we have, we want to remove average sales and we want to keep the customer total average. Remember, this will become, let me do that once again. Let's convert this into an average first, and then let's put this on label. And these are the numbers that we wanted. 215, 238, 241, 226 means that this is the average of each and every transaction. 796, 1007, 765, and 1057 means that this is the average of the customer totals. So how do we analyze and interpret this data? In terms of average, we would say that South region is the best in terms of average transaction size. But if you look at the total, the average of customer totals is also the least in South, which is giving a very interesting perspective. On the other hand, if you look at East, the average transaction value is 238, but the average customer total, that means that the average of which a customer is purchasing is 1007. So this was our first example, and this is a good way of understanding what level of detail expressions can do, which otherwise would not be possible on Tableau. We will do another simple example like this one in the next lecture, and after that we will look at more detailed examples. Please make sure to practice this a few times and get the hang of it. And I think it's a very good idea to also do this on Excel simultaneously, because that would allow you to understand what these numbers signify. I've seen a lot of people who are able to create LOD, but they get confused when it comes to interpreting these numbers. So please don't make that mistake. Make sure to concurrently do the same calculation on Excel so that you can see how these numbers are being calculated. In this lecture, we will look at fixed. Let's create a new sheet. And we want to keep region and state and the sales value. Now you would notice that Tableau is working exactly how we would expect it to work. That means that it is breaking the sales value for each and every state. That means if we remove the state, we can see the total of all the 4 regions. And if we include the state, then the number gets broken down. But what if we also want to see the total of each region next to the individual value for the state? To do this, we will create another calculated field and we will call this as fixed state sales. And here we would say fixed region and the sum of sales. What does it mean? It means that I want the sales value for the region to be fixed. So even though we have the state filter, the number is not going to get filtered. And the final result is going to look like this. So if you notice carefully, 80,000 is the sales value for Illinois, but 501,000 is the total for Central. 53,000 is for Indiana, but same number, 501,000 for Central. So if you remove the original sales value, you will get the result like this. I'm sure you can see why this can be very, very helpful. For example, if you keep them side by side, then maybe you can create another measure that can be a calculation. For example, dividing the value for the state divided by the grand total, like this. So lots of different creative ways in which LOD expressions can help you, but I hope you're getting the hang of it and getting comfortable with how to write it, and also able to see why we would not have been able to do these type of things on Tableau without using LOD. So we have done 2 examples. Let's look at a third one for exclude. Let's first create a chart. This time I want to keep a region and let's keep our sales value and we'll keep this in columns, and we also want to put our order date in the rows, and let's show the month and convert this into a horizontal bar. Perfect. So as you can see, we have 12 months. Let's also sort it. Just a moment. Yeah, this is okay. So as you can see, we have 4 regions, Central, East, South, and West, and we can see the sales for each of the 12 months, right? Like this. If you also want to see the label, just put it in the label, and you can see the label here. Now let's understand what we are trying to do. I want to use the exclude function. All right, which means that right now if I keep sales in my color, what will happen? You will notice that it is showing 8,211 and 137,000 as the complete range. So obviously we get a color spectrum from light blue to dark blue. But the problem is that if I only look at the month of September, the colors are different. It is looking at every single region, Central, East, South, and West, for the month of September as an individual entity. But we don't want that. What we want to do is we want to consider the total of September as one entity, the total of April is one entity. That means I want to compare the months with each other. I don't want to compare the individual region of every month. I want to look at every month. Basically, the entire June month will have one color, April will have one color, September will have one color, and so on and so forth. Let's see how we do this. Calculated field, and I'm going to call this region color. This time we want to use exclude, and we want to say we want to exclude the region and the sum of sales. So I hope that makes sense. What we are saying is that right now the colors are different for all the regions because Tableau is thinking that we want to look at every region separately. But we don't want to do that. We want to exclude the region from the analysis. We only want to keep the colors on the basis of the month that we have. So you would notice that when we keep region color as the color, we can now see one color for each month. That means January, February, March, all the different regions are presented as only one color. Let's quickly recap what is happening. If you look at the range, it is from 59,000 to 352,000. That means, for a moment, let me remove the region. And now I hope it makes sense. It is telling us that the lightest blue is for February, which is 59, and the darkest is for November, which is 352,000. And when we keep the region inside, despite the fact that region is a part of my visualization, the colors are not changing. That means that all the 4 bars for the month of September for different regions are presented as only one color, which means that this 62,000 and this 53 and even the small 24,000 all are a specific shade of blue because they all belong to one single month, which is October. Again, it's a very, very useful way of creating a lot more uniformity in the way you make your visualizations. If you want to find how many orders per customer, that's very simple. But what if you want to find out the number of customers with exactly one order, the number of customers with exactly 2 orders, and so on and so forth? We've already seen the basics of level of detail expressions, include, exclude, and fixed. Now let us look at this practical business problem. Customer order frequency. We look at the data set first. This is 01 data. We have city, customer ID, customer name, segment, order date, order ID, order priority, postal code, product category, the product container, the product name, subcategory, region, row ID, shipping date, shipping mode, state or province, discount, number of records, base margin, profit, quantity ordered, sales, shipping cost, and unit price. Even though we will not be using all of these things, it's good to understand the dataset broadly. The first thing we'll do is to go to Tableau and connect to this dataset. So because I've already connected Tableau to this dataset, let me open it once again. And text file 01 data. So we have a dataset here. Let's click on sheet 1. And the first thing that I want to do is to find out customer IDs and the number of transactions, which means I want to keep my customer ID in columns and we want to keep order ID in rows. Let's convert this into a column chart, but we're not able to do so because order ID is getting picked up as a number. So we want to make sure to change it to a distinct count. And let's also sort the data. And let's put this in my label. As you can see, it tells us that the customer ID 1193, the distinct count is 17. That means there have been 17 orders. Since we want this to look a little more descriptive, let me go to my tooltip and we'll also change this. We'll say that customer ID made count distinct orders like this. And let's also make this part bold. Perfect. So now when we press OK, you will notice that it gives us a very nice description that 1193 made 17 orders, 2882 made 16 orders, and so on and so forth. Now, if you notice carefully, 1, 2, 3, 4, 5. So if I select them, you will see that there are these 5 customers who all have made exactly 13 purchase orders. And that is the frequency that we want to see. Make sense? Now the question is, how are we going to do this? So just take a moment and think about it. We need to find out the distinct count of customer IDs as per the number of orders that they have. Fair enough. For this, we will go to analysis and create a calculated field. And let's make 2 curly braces. And we will say that we want our customer ID to be fixed because we want to find the number of distinct orders for each customer ID. Fair enough. Count distinct, which is count D of order ID. So take a moment and think about it. What we're doing now is we are saying that we want to find the number of distinct order IDs for each and every customer. All right. Now, once we have done this, now we have our count distinct order ID. Let's remove that. And we have a new calculation that we have created. In fact, we haven't given this one a name. So let's just make sure to give this a name as well. Edit, and let's call this number of orders per customer. Perfect. And let's put the number of orders per customer in the rows. Now, if you look carefully, we are getting the same result that we were getting earlier as well. Fair enough. What is the difference? This is the important part. The difference is that now this distinct count of order ID is a measure. That means we have calculated it ourselves. I'm sorry. What we are saying is that count distinct of order ID is a measure, which means that, let me do that once again. When we had taken the order ID and put it here and we did a count distinct, this was a measure. But when we are putting a number of orders in rows, what we are doing is we're essentially creating an expression. That means that we did this calculation ourselves. And because we have done that, we can now convert this into a dimension. That means we can now put the number of orders per customer and just drag it into the dimension. So it comes here. Let's make another sheet. And on this one, we want to keep the number of orders per customer in the column. And we want to keep the customer ID in my rows. And we also want to do a count distinct. Let's also put the count distinct in color. And let's also put the tooltip where we want to see the count distinct of customer ID. So we want to say that this is the customer and customers have made exactly these many purchases, right? Let's see the result now. So what does it tell me? It tells me that 1027 customers have made exactly one purchase. 479 customers have made exactly two purchases, and so on and so forth. You can put it in label if you want to see the numbers here as well. So if you notice here, this is the number that we had found out earlier manually, which means that 5 customers have made exactly 13 purchases. So if you remember, these 5 who have made exactly 13, these are the 5. If you look at 8, you would notice that we have 3, 6, 9, 12, and 16. Let's verify the number. So we're looking at customers with exactly 8 purchases, and with 8 we have 16 customers. So if you hover your mouse, it tells you 16 customers have made exactly 8 purchases. Wonderful. Now what is the significance for the business? This is super important because as a business you want to find out what is the average ticket count. That means that how many customers are placing only one order. That is not a good sign, because this means that there are a lot of customers that you have in your database who are purchasing from you, but they're not becoming repeat customers. If you look here, 2, 3, 4, 5, I would say that 479, 439, 366, and 224. So we'll say that about 1400 customers that I have are purchasing exactly 2 to 5. And this is very important for a business, because if you want to plan the purchase frequency for all customers in the future, you know for a fact that about 1400 customers are actually purchasing between 2 to 5. And that is how you can plan your customer loyalty. So please make sure to practice. This is the first example that we have worked on. We will do a lot more of these. As you can see, it's not really very difficult when you see the final result, but the steps have to be done in a certain order, and some of the steps can get a little complicated. Like where after we created the calculation, we had to drag it into the dimension. That is an area where I've realized that a lot of people get confused. So please make sure to practice this without watching the video or referring to the solution a couple of times till you get the hang of it. I will see you for the next lecture. Cohort analysis is again a very common analysis that we would want to do, usually used in marketing. We want to understand whether longer tenured customers make a larger contribution to the sales. What this means is that if a customer has been with the business for the last 4 years, does that mean that they are going to contribute higher this year versus somebody who has only been with the business for the last 1 year? Now, usually you would expect that a longer tenured customer is also a loyal customer. For example, somebody who has been purchasing from you for the last 5 years. But at the same time, you want to verify that whether older customers are actually contributing a significant portion to your sales or not. So we are working on this data set. We have category, city, country, customer ID and name. We have the market. We have the order date. So just pay attention here. We have 4 years, 11, 12, 13 and 14. That means there will be 4 cohorts of customers, 11, 12, 13, 14. The rest is very simple. We have order ID, order priority, product ID, product name, region, row ID, segment, ship date, ship mode, state, subcategory, discount, number of records, profit, quantity, sales and shipping cost. We don't really need all of these columns for our cohort analysis, we will only need sales and the year. But in case you want to try out different business cuts, you should be able to do that as well. Wonderful. So let's open Tableau and connect to our second file. Now, the first thing that I want to do is to put all my customer IDs in my rows, and we will keep the day of the order ID. That means how many orders have come for each of these customers. So you notice that, I'm sorry, we want to keep the day here. So that would be the order date, and we'll keep the order date and let's change it into the day. And let's make sure that we are showing this as a discrete value. Wonderful. Let's understand what is happening here. It is telling us that the customer ID AA3151 has made only one purchase, which is 31st July 2014. It is also telling us that customer ID 3152 has made 6 purchases, 8th of June, 8th of August, 27th of August, 19th of September, and so on and so forth. Fair enough. Now, we can also sort the data. So let's sort the data here. And we want to sort it in a, let's say, a ascending order. By the order date. Okay, that did not seem to work properly. Just give me a moment. So, okay, let's see if we can sort it here. Perfect. So you notice we have 8th of June, 8th of August, 27th of August, 19th September, 5th June, and 29th December. This means that there have been 6 transactions for 3152, 1 transaction in 2011, 2 transactions in, or rather 3 transactions in 2013, and 2 transactions in 2014. But there has been no transaction in 2012. We want to create another column in which we want to show the customer acquisition date. That means on which date did the customer make the first purchase. So on analysis, please click on calculated field, and we want to create the minimum. That means the first or the earliest date. So let's call this the customer acquisition date, and this would be fixed. We want to find for each customer ID the minimum order date. So this should be fairly simple. We have done similar fixed functions earlier. That means for every customer, I want to find out the minimum order date. The minimum order date would be nothing but the earliest transaction date, which is the customer acquisition date. Let's keep this next to this, convert it into a day, and let us see the result that we are getting. Make sure this is discrete and not continuous. Wonderful. So now you can see that 3152 has 6 transactions, which are in 11, 13, and 14, but the customer acquisition date obviously will be the same for that one customer. Fair enough. Similarly, for 4801, 2 transactions in 11 and 12, and the acquisition date is 21 June 2011. Okay, so we are getting somewhere. Now what we want to do is to create another sheet, and in this sheet we will keep sales value in the rows. We will keep the order date in the columns, but we only want to look at the year here. Let's make this into a column chart. Now, as you can see, it is showing us the total sale for all the 4 years. But now if I bring my customer acquisition date into my color, what's going to happen is, you notice we get 4 different colors like this. Fair enough. So let's understand what is happening. It is telling us that in 2011, the total sale is 2259,511. All right. And if we look at 2012, the sale is split between 1767986 and 909507. So what is happening here? It is telling us that there are different cohorts. That means that in 2012, there are 2 cohorts. In 2013, there are 3 cohorts. And in 2014, there are 4 cohorts. So let's keep one of the market as a filter. So we'll only evaluate one market for now. Let's keep EMEA, which is Europe, Middle East, and Africa. So what does it say? It says that in 2011, the sales is 136. In 2012, it is 64,000 and 98,000. But I would like the tooltip to be more descriptive. So let's click on tooltip. And let us say that in the year order date, so in the year order date, the year customer acquisition date, customer cohort generated the sales. So just think about what will happen. It will tell me the year, it will tell me the year of the customer cohort, and it will tell me the sales value. Let's see how it looks. So now it tells me that in 2011, obviously there is only one cohort which is giving us 136,000. If you look at 2012, the 2011 cohort is generating 64, but the 2012 cohort, that means the new customers are generating 98. And if you look at year 4 and you track the blue, that means if you track the 2011 cohort, you will see that their contribution is 136, 64, 96 and 134. So I would say that it has been fluctuating quite a bit. Okay, so let's try to show it in a different way. Let me duplicate the sheet. And on the sales value, please right click and select a quick table calculation. And in this, you want to select % of total. Once you have done this, again right click and then select compute using table down. So what this will do is it will present the same data a little differently. And I think this is better because this helps you understand the percentage contribution. For example, in 2011, obviously the 11 cohort is 100% contribution. In 2012, the 2011 cohort generated 39%, then 46, and then 44. So as you can see, in 12, the contribution was 39. In 13, the contribution became more, which is very interesting because despite the fact that we added new customers, which is this red bar in 2013, despite that, the overall contribution to the business of 2011 cohort has increased. But if you look at the 12 cohort, 60%, 28%, 22%. So this is not a good sign. Despite the fact that the year that they started, their contribution was 60%, over the years, their contribution has been declining. If you look at 13, again, you notice that from 24, it dropped to 70. So I would say that older customers are not necessarily contributing a lot to the business, but my oldest customers, which is the 2011 cohort, their contribution has been quite significant over the last 4 years. Again, you can present the data in different ways. I've just given you two ideas. One is like this, the other is like 100% stacked column chart, but you can present it any which way you like. In this example, we will look at daily profit KPI. To find out whether profit is trending over time is fairly simple. But what if we measure our success by the total profit for each and every business day? This means that if we have 30 days in a month, what if we want to find out how many of these individual days have been profitable? This will also allow us to find out seasonal factors. So we are working on this data set, which is 03 data. For our example, we will only be using two columns, the order date and the profit column. But in case you want to spend some time and get comfortable with the data, you can do that. We have 4 years with us, 2010, 11, 12, and 13. So let us go to Tableau and connect to 03 data. The first thing we want to do is to put order date in the rows, look at the day, and make it discrete. We have dates from the 1st of January 2010 till the 31st of December 2013. Now, if we put our profit in columns, and let's convert this into a bar chart, and also put the profit in the color and the profit in the label, we can see that this is the profit for each and every individual date. So negative 425, negative 473, negative 14,000, positive 2100, positive 3,500. Once we have done this, we need to find the daily profit KPI. But before we do that, we have to first create a fixed measure that would be the profit for a single date. So click on analysis and select calculated field. And we will say that our profit per day is fixed order date, and we want to find the sum of our profit. Like this, which means that we want to find the profit for each and every individual date. Press OK. Once we have done this, now we can find the daily profit KPI, which means we want to distinguish our profits as highly profitable, unprofitable, and profitable. So let's create a new sheet, analysis, calculated field, and let's call this our daily profit KPI. We'll use a simple conditional statement to say that if the profit per day is greater than 2000, then the result is highly profitable. Else if the profit per day is less than equal to 0, then it is unprofitable. Else it is profitable. And let's end this. Excellent. Now that we have done this, we can, in fact, we don't need to create a new sheet. Let me delete it and we can just copy the previous one. So we'll duplicate it. We already have the order date and the sum profit. What I want to do now is to put my daily profit KPI in the rows. And if you notice, depending on the number that you see here, it is telling me whether it is unprofitable or profitable or highly profitable. For example, this is unprofitable, which is 14,000. If I'm looking at 3000 is highly profitable. If I'm looking at 400, it is profitable. Good. So we are getting somewhere. Let's create another sheet and let's try to put everything together. So we'll have our order date in the column, which will be the year. Let's also break it down into the quarter and the month, but we don't need the quarter, so we'll remove it. Daily profit KPI will be in the rows, and we will select our order date and put it in the rows, but change it to a distinct count. Remember, we wanted to find out the number of dates in a specific month that are profitable, unprofitable, or highly profitable. Let's convert this into an area chart. Okay, just a minute. So let me try to convert this into an area. So it looks like this. So we have highly profitable, profitable, and unprofitable in the 3 rows. Now, if you want to put different colors, which we should, I think, we can simply select our daily profit KPI and put it in the color. And what is it telling us? As you can see, it is telling us that for the year 2010, if you look at every single month, okay, so this is a trend for all the 12 months. We can see that in January, we had 7 highly profitable days, then 6 in February, and then it kept on falling. But if you look at the month of November, we had 10 highly profitable days. Then we had 18 profitable days and we had 1 unprofitable day. So basically this means that November has been a very good month for us. That's it. So we managed to find out daily profit KPI. How many days in a specific month are profitable, unprofitable, or highly profitable? In this example, we will look at percent of total, where we want to find the contribution of sales by each country, ignoring the filters. We are working on the dataset 04, so you can spend some time and look at this. So let us first connect to the 04 dataset. Now, if we simply make a map, which means we want to look at all our countries, and we also want to look at the sales amount. And let's make this into a filled map. You can see all the values here. Now, if we also want to see the percentage contribution for every single country, what we can do is to change my sales into a percent of total. And if we put this in the label, we can see that United States is 18%, Russia is 0.66, India is 4.66. Now what is happening is that 18% of the global sales is coming from the United States. And because the United States is so dominant, we cannot easily make relative comparisons between countries in the same market, right? Because all these numbers seem so small because this one single country is 18% of the total sales. So what do we do? Let's first put sales and country. Let's sort the data. And we only want to look at one market right now. Let's look at the European Union. Let's also put the labels inside so we can see that we have 858,000, 628,000, 528,000, and so on. Next to this, we also want to see the total sales value, which means if I remove the country from here, you will notice the total sales is, just give me a moment. So what we want to do here is we want to look at the total sales for all the markets. That means if I remove everything, you will notice the number is 12,642,000, and that's the number that we want to see here. How do we do that? For this, we want to create a calculated field. So click on analysis, select calculated field, and just call this sum of sales. So we will write in curly braces the sum of sales and let's press OK. Let us take a moment and see what we have done. Now, the original sales that we have is the sales for each country. But when we create a calculated field, this one that we have created, this is the sales for the total global sales. This means it's a fixed calculation. Because we have put the curly brace, this has become fixed. That means that if we put this in our column, you would notice that we get. So don't worry about these labels that you're getting. The labels are actually incorrect. Let me put this as the label, and you can see that we are getting the same number everywhere. So remember, the sum of sales in the curly bracket is a fixed calculation. That is why the result comes like this. Excellent. The next thing we want to do is we want to divide the sales of each country by the total value, which means we want to create another calculated field. And in this calculated field, we want to write sum of sales, and we want to divide this by the minimum of my sum of sales, like this. So let me just check the syntax once. So sum of sales is okay. Then we're dividing it by the minimum, and in this we are writing the sum of sales which we have already created, like this. Perfect. Just give me a moment. Let me do it once again. Whenever you get stuck, it's best to do it from the beginning. So we want to write curly brace and then the sum of sales, like this. And we also want to close the curly brace. Perfect. Now you must be wondering, what is this minimum doing here? Now this is a very advanced topic. What happens is that we want to divide the sales for each country by the total value, but the sum of sales has to be aggregated, since we cannot mix row level and aggregate calculations. And that is the reason we're using min. You can use max as well. If you're interested, you can just go online and read about it. But the basic idea here is you cannot mix row level and aggregate level calculations. All right, so we have created the calculated field. And now what we want to do is we want to select our, oh, I don't think I gave a name there. So let me just quickly click on edit and let's call this % of total. Excellent. So now this % of total can be put in our columns, and you can see the percentage contribution here. Let me just try to change the data type. Just give me a moment. So let's click on format, and my field is my % of total, and I want to change the number into a percentage, right? Let's see if that works. Number into a percentage. All right, that doesn't seem to be working. Just give me a moment. So let me again change into a percentage, and into a percentage. Perfect. So as you can see, it is telling us 6.79%, then 4.97, 4.18. What are these numbers? This is the division of the sales for a country by the grand total. Fair enough? And we're looking at the countries in the European Union right now. Now that we have done this, we can now again keep the market in filter, select European Union. We will make a map with our country and the percent of total that we have taken. We will make this into a filled map, and let's keep the percent of total in our color as well as our label. So that seems okay. And if you notice now, what it is doing is it is basically telling us, let me just change the format once again. So my percent of total, we'll have to format one more time, where we'll have to make this into a percentage like this. Perfect. So we can see 6.79, 0.12, 4.18. So just take a moment and think about what we are doing right now. What we are saying is that France has 6.79% of global sales, but it is the highest performing country in the European Union. Right? So I hope that makes sense. We are saying that the contribution of Germany to global sales is 4.97, but it is also a large contributor for the European Union. So if you look at the first map, and we are only looking at, let's say, one market right now. So I'm going to keep my market in filter and select European Union. You will notice that this is telling us 29%, 21%. What does it mean? This means that this is 29% of only the European Union. This is 21% of only the European Union. But now what we have done is we are basically comparing a country to the entire world. But at the same time, we are only looking at one market right now. So you will best understand it when you keep both of these side by side, this one, and that will help you understand what is it that we are doing. So it's a very important example that we have done, and especially when you're working with maps, this can really help you. Not just with maps, but wherever there are multiple product categories and you want to understand as a part of a portfolio and as a part of the entire business, you might want to look at both these numbers because both of them have their own significance. Let us look at new customer acquisition. We want to see whether the efforts that are being put in by regional and sales teams are helping generate new business for the company or not. The steeper the line, the better is the acquisition trend, which means that we continuously keep on increasing the number of new customers who are joining the business. The moment the line starts to flatten out, it means some action has to be taken. Let's see how we do this. So we are working on this data set. This is 05 data, 50,000 records. Let's import the data set on Power BI. On Tableau. Once we have the data set with us, what we want to do is to create a trend line with the years on the x-axis, and we want to see for all the different regions, what are the total number of customers that we have acquired for each market. Let's see how we'll do this. The first thing we want to do is to find out the first purchase date by fixing the minimum order date. So remember, we have already done this analysis calculated field. And what we want to do here is to find the first order date. All right, so we want to call this as the first order date, and this would be curly braces, fixed customer ID, and we want to find the minimum order date. Once we have created this, we can now put our customer ID. So just give me a moment. Let's put our customer ID, which I can't seem to find for some reason. Let me quickly check the dataset once again. Okay, so we do have the customer ID here. Let me quickly come back and see why I'm not able to find it. Okay, it's here. So we have the customer ID. We'll put it in our rows. After that, we have the first order, right? So we want to see the order date first, and we also want to see the first order date. Let's just change the order of these different elements a little bit. So we'll first have the order date, and then we'll have the first order date. Like earlier, we want to make this a day. This will become discrete. Same thing. We want to make it a day. And we want to make it discrete. We can now see that 3152 has had 6 transactions, 11, 13, 14. And 8th June 2011 is the first order date. What we need to find out is a result, which is a binary result, telling us whether one transaction is new or existing. That means if you look at AA3151, there is only one transaction. So obviously, this is a new customer. If you look at 3152, you will see that the first transaction happened on the 8th of June. That means that on the 8th of June, he was a new customer, but for all the others, he became an existing customer. So let me also sort the data. That will make it a little simpler for us. So we want to sort it as per the order date. And let's quickly check this. So we want to sort as per the order date. Okay, that seems to be working. So we have 8th of June 2011, 8th of August 13, and the last transaction is on 29th of December 2014. We need to find out whether the customer is new or existing. To do this, we will have to create a calculation. So we go to analysis and create calculated field. And here we want to say new or existing. So we will say if, remember this is a double if, my first order date is equal to my order date, then the result will be new, otherwise it will be existing. So this should be fairly simple. And when we put this result of new or existing in the row, you will notice that it tells us new and existing. So if you look at 3152, the first transaction is new, but for all the other 5, he's an existing customer. Good, so we're getting somewhere. And now we can make another sheet. We want to put our order date and change it into the day. Then we want to keep our customer ID and put it in rows and change it to a distinct count. Let's change it into a line. Once we've done this, we can also put our new or existing as a filter, and let's only select new. Now we can select our distinct count and do a quick table calculation to see a running total. So I hope this makes sense. Because we don't want to see a trend line, we basically want to see the distinct number of customers as per the time period, but as a running total. That means we want to see the cumulative. So we will get a running total like this. So if you notice, when we started the business, we had 0 customers, then we gradually kept on increasing the number of customers that we had like this. And if you notice, it is very steep till about the 7th of January, and after that it starts to flatten out. Finally, if you want to show this for different markets, you can simply select your market and then put that in the color, and you will get a different line for each of the markets. So if you notice, I would say around this second week of January is when things started to become bad. So if you notice in North America, I was very steeply increasing the number of customers, but after the 12th, or rather the second week of January, you notice that it started to flatten out. And there could be many reasons for that, but this is how we have enabled the business owners to understand the pattern of customer acquisition. We can also make the tooltip a little more descriptive. So we can say on, just a minute. Okay, so we'll say that on the day order date, the market, which is the market, had acquired a total of, and now we can keep the running sum. So let's look at the result. So now it will tell us that on the 24th of January 2012, North America had acquired a total of 638 customers. In fact, let me add customers here as well. Perfect, like this, right? So you can see how steeply they were increasing, and then it started to flatten out. Let us look at comparative sales analysis. If you want to find the average and then find the difference from average for all the categories, that's very straightforward. But what if you want to find the difference from a selected category? To do that, you will first have to isolate the selected category sales, and then you have to use an exclude expression. Let us see how we do this. So we are working on the dataset 06. We have about 9,000 records. For our dashboard, we will only be working with category column and the sales column. Let me also make sure that I have removed the $sign from here. You will not have to do this. The file that I share with you will not have the $sign in it. Okay, so let's come to Tableau and connect to 06. Let's go over the steps one by one. The first thing that I want to do is to keep my sales amount and my category. And we are looking at the data like this. Very straightforward. We can also put the sales in label so we can see the numbers. What we want to do now is we want to look at the selected sales. All right. Now, selected sales is going to be a calculated field that we are creating, which means that if the category is equal to the category the user is selecting, then I want to show the sales amount. So first we have to create a parameter. So let me click on the drop down and select create parameter, and we will create a parameter called category, and this would be a string and a list, and the values would come from my category. So all the categories have been mentioned here. Let's also keep this parameter somewhere where the user can select it. So show parameter, and as you can see, the user can select any of the parameters here. Now you have to create a calculated field, which would be the selected sales. Okay, so just take a moment and think how we would want to go about this. So what we want to do is we want to create a calculation called the selected sales, where we would say that if the category is equal to the category, which is the parameters, right? Notice the case difference. The category is coming from a field, which is in the original data, and the uppercase is coming from the parameter that we created. If both of them are matching, then I want my sales value. Otherwise, I want to simply show a 0, and let's end it. So we have a selected sales. Let's put this in columns. And you would notice that it is only showing us one number. Let's also remove the label from here. It is only showing us appliances because we have selected appliances. If we select something else, let's say envelope, it only shows us envelope. That is what we wanted to see. Let's put this in the label. Perfect. So what we have done is we have basically excluded all the others. We have only kept the category that the user is choosing. Now we want to look at sales of the selected category. That means we want to create a list of numbers, but all the numbers would only show us one constant, which means if I'm selecting envelopes, all the numbers here should be 147915. If I'm choosing bookcases, then all the numbers should be 407377. Let's duplicate the sheet and remove this. Go to analysis and create another calculated field. And here we want to write sales of the selected category. That means I am only interested in showing the sales of the selected category for every single category. So we'll have to use a level of detail where we say exclude the category and then find the sum of selected sales. Right? Let us see the result now. So now when we put sales of selected category in columns, you will notice that. Let me remove this and keep the data label. You will notice it is only showing us 407377. Let me increase the height. Why is it 407377? Because we have selected bookcases and bookcases is 407377. If I choose labels, then I get 23,446. And this is exactly what we wanted. What we want to do after this is to find the difference, which means we want to find the difference from selected. We already have the sales amount. We also have the sales of selected category. So analysis and calculated field. Let's say this is the difference from selected. This would be the sum of sales minus the sum of sales of selected category. So I want to create a duplicate sheet, and on this we want to remove this and we want to put the difference before our original sales value. Let's also remove the label. So from difference, we want to remove the label and we want to keep the difference as our label here. Okay, let's sort the data and see how this looks. So I'm going to choose, let's say, storage and organization. So what is happening here is that it is telling us that storage and organization is my benchmark. So I'm comparing everything against storage and organization. So what do we see here? We obviously see that this is 0, difference from selected. But if we look at binders, it shows us 52,000. That means the sales for binders is 52,000 more than storage. All right, so 585,638, the difference is 52. If I select something else, for example, tables, you notice that there are only 3 categories that are doing more and all the others are below tables. And that is what we wanted to present. So there are 2 things. We are looking at the difference in sales, which is 423,000, which is negative 423,000. And we can also see the actual sales value. Now, what is this number? This 1218655. So this 1,218,000, just remember this number, office machines. If we go back to the original data, and if you look at office machines, you notice this is the same number. That means this part, the second bar chart that you have is showing us the actual sales, while the first one is showing us the difference from the selected category that we have. Once we have done this, we can now put some colors as well. So let me select my difference and put it in color. So this looks much better now. From the sales, we don't want to keep the color, so we'll remove it. And what we in fact want to do with sales is we just want to keep, let's try a different color here. So we'll use color and maybe we can just keep, let me think what we can do. So we want to use selected category and not selected, correct? So let's me try to put our selected category in the color, and now you notice we get 2 different colors, one for the selected, all the others for the not selected. Of course, now we can change the colors. So let's make the not selected as gray and let's make the selected category as green, right? In fact, let me see if I can select a gray palette. I think that would look better. Not selected is white and then selected is a gray, like this. So I think it looks much cleaner now. What we're looking at is we can select any category here and you notice it will tell us the total sales for that category and the difference from all the other categories that we have. In this example, we want to look at the average top deals by the sales rep. What we want to understand is that if there are multiple sales reps, they have several deals that they're closing each year. And if we look at all the deals that they are closing, there has to be one deal that is the largest deal, which basically would be the largest sale amount. What we want to do now is we want to look at all of the largest deals closed by the sales rep for one country. So let us say there are 50 sales rep in United States and each of them has 50 transactions each. So we just want to look at the top 50 transactions, one each for one of the sales reps, for each one of the sales reps. And then we want to average them out. We are working on the dataset 07. This is a different dataset to the ones that we have been working on. So we only have 5 columns with us. Country, the deal ID, the sales rep name, sales and transaction date. The number of records is only 1. That means that for one country, one deal ID would only come one time. But there can be a deal ID which is there for multiple countries. But one country cannot have the same deal ID multiple times. Let's bring this data to Tableau. So we have 07 data. The first thing we want to do is to double click on country. And we also want to look at the sales amount. And let's put the sale in color. Now let's understand what is happening. It is showing us the total sale, but I want to look at the average, so we can change it to an average. Let's also change the color. So edit color, and I'll change the palette to orange, blue, diverging. Okay, so it's a little easier to understand the data now. If we look at the data, let's not look at this. If we simply right click and then duplicate as a cross tab, we can see that this is the data that we have. So we have the country and we have the number, which is the average sale amount. Now what we want to do is, we want to understand that the granularity of the data right now is the deal ID by the sales rep by the country. So going back to the Excel, the granularity is the deal ID by the sales rep by the country. For example, the first record is the deal ID 5123839. The country is Indonesia and the sales rep is Jim Radford. But this is not what we want, right? This is not how we want to plot the map. So let's see what we want to do. Before we take the average, we want to make sure that we want to look at a level of detail to find the maximum sales by the rep and the country. Not all the transactions, only the maximum one. To do this, we have to use max sales. So click on analysis and create a calculated field. Once we've done this, we can give it a formula and we can say we want to find the largest sales deal by the rep. So largest sales deal by the rep. And this is simple enough. We want to say we want to include the sales rep. That means for every single sales rep, we want to find the maximum sales amount. This means that only one transaction will be shown for each sales rep. Okay. Once we have done this, we can create another sheet. So I'm just duplicating the first one. We don't need this one. So let me remove this. And rather than keeping the average sales, we want to keep the largest sales deal by rep in the color. Just like earlier, let's change the color palette to orange, blue, diverging. And now my result looks like this. Let me see if I can try a different combination. Let's see which one will make the data look a little better. So we can try I think we can stick with this. This is okay. This tells us what we want. So the oranges are the smaller numbers, which is 1937, and this 1384344 is the largest. But we want to look at the average, remember? So we will look at the average, and now my result looks like this. Let's understand what is happening. The range, if you notice, is 1903 till 4533. That means that if I'm averaging all the top deals in a country, then the range is between 1903 and 4533 for all the countries. That means if I'm looking at Russia, Russia has several deals that have been closed. Let's say there are 100 deals. Now these deals are the top deals. If I average all of them out, the value is 3453. Fair enough. Similarly, if I'm looking at China, China has a lot of deals. There are different sales rep. But if I only identify the top deal for every sales rep and then I average all the top deals, then the average comes out to 3316. So we're getting somewhere now. So please make sure to keep creating all the sheets alongside me. That will make it simpler. Let's create another sheet now. Here we want to keep our sales rep in the rows, and we want to select a maximum sales in the column. So let me change it to maximum. And I also want to draw a reference line into the view. So from the analytics pane, we can just put a reference line inside. And you have to be careful here. When you put the reference line inside, you want to put it on the table like this. Let's see how this looks. Let me also sort the data. That will make it a little simpler to understand. And as you can see, we have Sean Miller, who has the maximum transaction of 23661, followed by Tamara Chand, who's 18337. And if you look at this reference line is 3231, right? Which is the average for all the sales rep. Let me also right click and edit the reference line and see how we can show the value. So let me quickly show the value. Okay, so at the bottom, you notice we can see the value here. All right. Now that we've done this, what else do we want to do? Now, this is something different. What we want to do is to create a Boolean calculation that identifies if a sales rep is above or below the average top deal size. Now, we can write a level of detail expression for this, but it is simpler to use a table calculation. So this is a little different, and we haven't done this earlier. So just make sure to look at this and follow this. Let's go to analysis and please click on calculated field. Call this conditional formatting because we want different colors. And here you will say that max sales is greater than the window average. So that's an inbuilt function. And in window average, you again want to select max and sales like this. So the calculation is valid and press OK. Once you have done this, you can put conditional formatting in the color and you notice that we will get two colors, false and true. So if you scroll down, you would notice that orange is where the top deal by these sales rep is higher than the average, and the blue is where it is lower than the average. Of course, you can swap the colors on or change it however you wish. Great. So this was something different, not complicated, but something we haven't done earlier. And now we can create a dashboard. So let's create a dashboard. We want to select the map and bring it inside. Let's also select the bar chart and keep it below this. And on the map, we want to say use as filter. Let me also increase the resolution. So let's make it a little wider. And let's see what is going to happen now. We have all the countries here. Let me in fact go full screen. We have all the countries here. So let's say I click on Brazil. 3246 is the average. When I click, you notice that it shows us the average, which is the reference line 3246. And I can also see the maximum sales for all the sales rep. So who's above and who's below the average. Let's say we're looking at Australia. So you notice that there are lots of sales rep whose largest deal size closed is much higher, sometimes 4 or 5 times higher than the average. For example, here it is 14,000, and there are also certain sales rep whose maximum deal size is only a third of the average deal size. This is how we can present the data. We don't really need these things. So if you want to make it a little cleaner, you can simply remove all of these things. And this is how the final dashboard can be presented. So once again, a quick recap. What are we trying to do here? As a business, I want to understand for each sales rep that I have, what is the largest deal size that they have closed in each country? So these numbers that you see, 3496, 3169 is the average size, which is the average of the largest transactions. 3231 is the global average, but if I click on China, it shows me 3316 is the average for China. And why do we want to look at all the sales rep? Because we want to see how many sales rep had a maximum deal size closed higher than the average and how many had a deal size lower than the average. So please make sure to practice this a couple of times, and I will see you for the next lecture. In this example, we will look at actual versus target. Now this seems simple enough. We want to compare the actual profit versus the target profit. The problem is that if we only look at the total for the actual profit and the target profit, we might miss some nuances. For example, if I get to know that New York has the actual profit larger than the target profit, that doesn't tell me much as far as the products are concerned. For example, if I'm selling 15 products in New York, it is possible that 14 of these products did not meet the target profit, but the one product that did meet the target profit was such a high actual profit that the overall for New York also became profitable. In this example, what we want to do is to find the target achieved at a product level. That means we just don't want to find whether the entire state is profitable or not. We want to find whether every single product has been profitable or not. For example, we want to know whether in New York, 50% of the products met their individual target profit, or 30% met it, or 90% met it. We are working on the dataset 08. It's a smaller dataset. We have 1,000 records with us. And we have different details here. For example, we have the profit, the sales amount, target profit, and the target sales. Let's load this data on Tableau. So we come to, okay, this would be a CSV file and 08. The first thing that we want to do here is to simply look at the difference between the target profit and the actual profit. For this, we will have to create a calculated field, and we can simply click on analysis and please click on create calculated field. Let's call this actual difference between actual and target profit. This is equal to nothing but the profit minus the target profit. Simple enough. Once we have done this, we can now put our state in our rows, and we can put the difference between actual and target profit, the one that we just created, in our columns, and we can also put this in our column. Let us sort the data and put the label as well. So you can see that Iowa is positive 1152, Utah is negative 741, right? Simple enough. Now let's make it a little interesting. Like I said, we want to now look at the same result on a product level, which means I want to create another calculated field. So let's create a sheet and go to analysis, create calculated field. Let's call this the difference between actual and target by the product. This would be a level of detail expression, which is I want to include the product level and then I want to sum up the difference that we have already calculated. Fair enough? So not for each and every transaction, but for each and every product level. Once we have done this, in fact, I can just duplicate the previous sheet. That would be easier. Let me delete this one. And here we want to remove this and keep the difference between actual and target by product. Let's keep it in the label and let's keep the same thing in the color as well. Now you would notice that these look exactly the same, which they do, but do remember that now we are looking at a product level. Now comes the interesting part. Let me duplicate it once again. Now we want to look at the count of all the product, which is the distinct count. So let me put my product in my columns and we want to change it to a distinct count. Let's keep it after this. We don't really need the colors, so we can remove that. So in count distinct, we can remove the label and the color. And let's replace the label with the distinct count. So 9, 8, 12, 6, 11. This tells us how many unique products am I selling in all these states. Now what do we want to do? Now we want to look at the number of products that are above the target. So click on analysis and create a calculated field. This would be number of products above the target. It's a simple conditional statement. If the difference between actual and target by product is greater than 0, then I want to show a 1, otherwise I want to show a 0, like this. Once we have done this, we can put this also inside our columns. And if you look carefully, what are we looking at right now? It is telling me that there are 9 unique products that are there being sold in Iowa, out of which 4 have met the target. 8 out of which 6, 11 out of which 6, like this. So we are getting somewhere. This is exactly what we wanted to create. Now what do we want? We want to find out the percentage of products which are above the target. Basically, we have the total number of products, we have the number of products that are meeting the target, but we want to find this as a percentage. So 4 divided by 9, 6 divided by 8, and so on. So let me create a duplicate sheet. In this one, let me remove the distinct count and the number of products. Go to analysis and create another calculated field. And this time you will say the percentage of products above target. And this would be the number of products above target divided by the count distinct of the number of products. What will it do? It will return a percentage for me, and let's put this in the columns as well. Let's change the label. So the color in the label I'm going to change. Let's put the percentage in the label, and we also want to format it to make sure it becomes a percentage. Okay, perfect. Let me now sort the data as per the percentage. Let's see how we will sort it. Just give me a moment. So we should be able to, okay, Just give me a second. Yeah. So what we're doing right now is that we are looking at Illinois, and 77% means that 77% of the products being sold in Illinois are meeting the target profit. If I look at Oklahoma, 42% of the products being sold are meeting the target. But here's the question. Even though the 77% is a really good number, what is this negative 80? This is interesting. This means that despite the fact that 77% of the products being sold in Illinois are meeting their individual target profit, overall as a state, the state is negative profit. It's incurring a loss. If you look at Massachusetts, such an interesting story. Only a third of the products being sold are meeting their individual target profits, but the overall profit is 490. Now, I'm not going to comment on what is good and what is bad, but this definitely is an interesting insight because we should really be looking at both of these combinations. We should not be looking at only the overall profit or the loss because that doesn't really tell us much about how individual products are performing. So I hope you like the example. This is what we have done. If you want to convert this into a dashboard and probably show multiple things together, you can do that as well. But as it stands, this is what we wanted to do. We wanted to see the overall profit or loss, and we also wanted to see the number of products that are being sold, which are also meeting their target profit. In fact, let's also create the dashboard. So we want to create one more sheet before we do that. Let's keep our total profit in our rows and we keep the product in columns, and let's also sort the data. Let this be a column chart. Then in the color, we want to keep the difference between actual and target profit. And now we also want to look at the label. So the difference between actual and target profit comes in the label. And it looks like this, right? What else do we want to show here? We can see the profit. We can see the difference between actual and target profit as well. What we want to do now is we want to put an additional element. That means right now how the chart looks is great, but I also want to use a reference line. Let's see how we do this. So I'm also first going to put my target profit in my detail so that I get three things in the tooltip: the difference, the profit, and the target profit. What else do we want to do? For a reference line, I will right click on the vertical axis and click on add reference line. Here we want to add the sum of target profit per cell. Sum of target profit per cell. Right? Just look at the difference here. So when I select per pane, we get only one reference line, but when I say per cell, we get a different one for each one of the columns that we have, which is considered a cell here. So what is happening right now? It is telling us that the average target profit is 6760, which you can also see here. But what is this column showing? It is only showing you 4687, right? So you can see the gap here basically. If you don't want to show this average text, you can also come back and let me just see. Let me remove the tooltip. That did not help. Just give me a moment. So we can edit it and the label will be none. Yeah, so we only get the bar here. As a matter of fact, we don't even need these numbers. So let me remove it from the text. I think this is all that we wanted to show. Once we have done this, now we can create the dashboard. So let's create a dashboard. I'll increase the width And what all do we want to put here? We want to select the sheet, which is sheet number 13, and then I want to put it inside. No, not this one, the other one, 14, where I can see the overall target versus actual plus the number of products that are meeting the target individually. And below this, we will also keep sheet number 5 that we just created. And it looks like this. Let me hide this. And I want to use the first visual as a filter. So use this filter. And once we go full screen, let us see how this looks. So what is going to happen is that I can select any one of the states from the top. Let's say I select Iowa. So you notice that in Iowa, I can see that for all of these different products that I'm selling, I can see that my target profit was 1180, my total was 1580. That's why this column is higher than the bar. And the difference is 400. That means I actually did 400 more than what was expected of me. Fair enough. And I can do this for any one of the states that I have with me. So just take a moment and think about it. Why we are creating a dashboard like this. Like I said, this can be very, very handy because now you can also see how many products are meeting the target. So this 1152 for Iowa, if I click on this, I can see that my 1180 and 1580, right, is the average, and I can look at the difference. If you look at decaf espresso, you will notice that the target profit was actually a little higher and my actual profit was a little lower. So when it says it's 44%, or let's select Illinois, when it says that it's 77%, I hope it makes sense now. It means that I'm selling 1, 2, 3, 4, 5, 6, 7, 8, 9 products in Illinois. And out of these, if you notice, only 1 and 2 products have not met the target profit individually, right? And that is exactly what we wanted to show. In this example, we will look at return purchase by cohort. We have already done the cohort analysis, and we know that it refers to the customers who started purchasing in a specific year. In this example, we want to see whether existing customers are making repeat purchases or not. For example, some customers might be taking 2 quarters to make a repeat purchase. That means they do not purchase in 1 quarter. And other customers might be purchasing every quarter. And there might be a customer who purchased once and they did not purchase for an entire year. That means did not purchase for 4 quarters and then purchased once again. And there might also be some customers who have never made a repeat purchase. So this is what we need to find in this example. So the first thing we want to do is to connect to our data set. This is 09. Data. The first thing we want to find is the first date of the purchase. So if you remember, we have already done this once. We want to write a calculation. So please click on Analysis, Create Calculated Field. And we want to call this the first purchase date. This would be our level of detail expression, which is fixed customer ID. That means for each customer ID, we need to find the minimum order date and that would help us understand what was the first date of purchase, which is nothing but the customer acquisition date. Once we have done this, we can put our customer ID in rows. The order date also comes in the rows. Let's convert this into the day. And also make it discrete. So we can see all the different days on which the customer is purchasing, and we can put our first purchase date also in the rows. This is also a day. As well as discrete. Wonderful. Once we have done this, we want to continue this process and want to find the day of the repeat purchase. So think about how we would go and do this. We know the first purchase with us, but we want to find the repeat purchase. To do that, we want to create a calculation. So click on analysis and calculate field. Call this the repeat purchase. And we will say that if the order date is greater than the first purchase date, then I want to show the order date. Otherwise, I want to show a null value. So what will happen is that if you look at the data set, for all of these states, we will get a null. Or rather, for all of these states, we will get a value except the earliest date. So you will notice that when I put my repeat purchase here as well, convert this into a day, and also make it discrete, you would see that it is showing us the 31st of July. Now, obviously, there is no repeat purchase for this customer ID. But if you look at the other customer IDs, for example, AA3152, you would see that 8th June was the earliest purchase, which is the day of first purchase. And the day of repeat purchase is all of these dates, except the first one is coming as null. Excellent. Now we want to find the day of the second purchase. To do this, we want to again click on analysis and please click on calculated field. And here we want to say the second purchase, which is the same thing. It is a level of detail expression, which is fixed, customer ID, and minimum. But rather than using the original order date and find the minimum, we want to use the repeat purchase here. So what will happen is that when we want to find the repeat purchase, if you look at AA3152, obviously the repeat purchase is coming as null. So the earliest date will come as 8th August. And I hope all of you can guess what the final result will look like. Let's convert this into a day. Also make it discrete. And you notice that we are getting the 8th of August here. So let's understand. 8th June is the first date of purchase, which is what we have mentioned here. 8th August is the second date of purchase, which we have mentioned here. Remember, the repeat purchase was only an intermediate calculation that we used, which allowed us to find the second date of the purchase. All right, so now we're getting somewhere. What we want to do next is, we already have the first and the second purchase dates correct. We can calculate the gap between these dates. So let's do that. Analysis and create a calculation, calculated field. And here we want to find out, in our example, we want to find the quarters, right? So the quarters to a repeat purchase, and this would be date diff, which is the difference between two dates. The date part that we're looking at is the quarter. So I'm going to put this in quotes. And then we need the start date and the end date, which we already have with us. So we have the first purchase date and the second purchase date. Everything looks okay. And we don't really need the repeat purchase for this, so we can duplicate the sheet. And I'm going to remove the repeat purchase option. So we only have the order date, first purchase, second purchase. Let's also rotate the label. That looks a little better. Let's increase the height. Perfect. And now we want to put our new calculation, which is quarters. But do remember that the first thing we want to do is to put our quarters in the dimension. So we want to drag it and put it in dimension. And now the quarters can be added in rows. And if you notice, it is telling us the number of quarters here, which means the customer EE3152 purchased for the first time on the 8th of June 2011, which was the date of the first purchase, and the second purchase was the 8th of August 2013, and that means there was a gap of 9 quarters. If you notice, 3751 is 1 quarter, 6th January, 16th April, and if you scroll through the list, you will see that there are also a few nulls. So if you notice here, 128053 only purchased one time and doesn't have a second purchase date. Obviously, because the second purchase date is not there, we also don't have the difference between the first and the second purchase date. Let's make the visualization now. Let's bring the quarters to repeat purchase in columns. And please make sure to select dimension. All right. Okay. So once we have done this, we want to put quarters to repeat purchase once again in the column. Let me do that once again. And we want to select discrete. Okay, let me quickly see if there's something going wrong here. Just a minute. Okay, let's start to add different components and then it will start to make sense. Let me put the first purchase date in the rows, and we only want to see the quarter here. So we select the quarter. And we also want to make this discrete. Okay, and we want to bring the customer ID in the color. Okay, so this makes a little more sense now. And we want to make sure this is our distinct count. Okay, much better. All right, so let me see if this is looking okay. So we have our quarters, but we need the quarter for every year, correct? So we want to make sure to select this one. And also make sure that this is discrete. Okay, so this is starting to take a much better shape now. In fact, we don't need it 2 times. So I think this is all we need. So we need the quarters for all the years here in the rows. In the column, we will have the quarters to repeat purchase. And if you notice, we get a very nice looking heat map. And how do you present this data? The darker shade means that a larger number of customers are there. For example, you notice that there are a very large number of customers, 156, 168, 151, which are the unique customers where the quarters to repeat purchase is 1, right? And if you notice, when we go down in 11, 12, 13, 14, 15, we have fewer customers. So what does it tell us? It tells us that if you look at this period of Q2, Q3, Q4, Q5, I'm sorry, Q2, Q3, Q4, Q1, Q2, Q3, Q4, this area for 2 years, you will see that there are a lot more dark colors here. This means that there are a lot of customers that are coming here. And at the same time, if you look at the null value, remember the null is nothing but the lapsed. which means the customer never purchased again. You notice that we have a lot of customers who have purchased from us one time but never purchased post that. Of course, if you want to see this for a specific market or a region, you can put the market in filter. Let's select Africa. And I can see for Africa, the results look very different. If I choose something else, let's say Asia Pacific, the results look very different. Now, don't be surprised if a lot of these are blanks, because what is happening here is that there are no customers who purchased in Q2 2012 who basically never like they never had a repeat purchase which they took 7 quarters for. I think the only thing we need to do here is to also change the tooltip, because it doesn't really express what we are doing, and it has to be a little simpler for the end user to use. So I'll click on the tooltip and we'll change it a little bit. So we will say that first we will keep the count of the customers. So I'll put it in the front. Let's increase the size. So we'll say that these many customers with a first purchase in, and here we want to put the quarter of the first purchase date, had how many quarters to the repeat purchase? That's what we want to show. So we want to say had these many quarters between their first and the second purchase. Okay, I think it's a lot clearer now. And if you see the result, we will see this. It tells us that, let me also make it bold. So this is bold, our quarter is bold as well, and the number of quarters is bold as well. Excellent. So we can see that, let's look at one. So we can see here that we have 4 customers with the first purchase date in Q2 2011. That means they purchased for the first time in Q2 2011, and then they had 3 quarters between their first and second purchase, right? Like this. So it's a very important analysis and very useful for e-commerce and consumer packaged goods companies, because you want to make sure that customers are purchasing from you repeatedly. Now, if you only look at the fact that they are purchasing, it would really not allow you to look at this drill down analysis. Also, from an RFM analysis, where you want to look at the recency and the frequency and the monetary value, it is very important to be able to do a visualization like this. I would encourage you to explore and try presenting the data using different visuals. It's not that this is the only way to present it, but this number that we calculated, the quarters to repeat purchase, that is the important part. In this example, we want to look at user login frequency. As a business, you might want to know how many users are logging into a website or an application. Once a month, once a week, or several times a day. What is the average login rate? And also, how does the distribution skew around the average? Now, the data granularity that we have here is the login date per user ID. That means we have one row for each day that a user logged in. So what we want to do here is to basically end up making a visualization which will have a distribution skew, and it will tell us what is the percentage of users that are logging in at least once a month or maybe once in every 3 months. It's going to be a slightly long example, so let's start working on it. The first thing I want to do is to connect to my data set. So let me just name the file properly. So you have to connect to a CSV file, which is 10 data. The data is very simple. We have the login date, market, market one, and the user ID. So let's do it one by one. The first thing I want to do is to put my user ID in rows. The login date also comes in the row. We want to look at the day here, which is this. And like we have done earlier in the last few lectures, make sure to convert it into discrete. We also want to look at the first login date. That will be simple enough. So analysis and click on calculated field. And the first login date will be a level of detail expression. We were writing fixed user ID. That means for each user ID, we want to find the minimum login date. That's simple enough. We put it in rows, convert to day, and make sure that this is discrete. So we can see that 3152 has multiple logins, but we can see the day of the first login here. Similarly, we need to find the day of the last login as well. So click on analysis and calculated field. This is last login, and this would be exactly the same thing, which is fixed user ID, but the max of the login date. Let's put this also in the rows. Convert to day. And discrete. Excellent. So we can see the first login is 8th June and the last is 29th December. Once we have done this, we want to find the total number of months that the user has been active. So let's create a new sheet. Click on analysis and calculated field. And this would be the total months that the user is active. This is date diff. So the difference between two dates. We only want to find the month here, which is my first login and my last login. So let's put this in columns. User ID is in rows. And we also want to keep the first login date and the last login date. Let's make both of these the day and make it discrete. This one will also be the day and discrete. Excellent. We want to make this as a bar chart. Let me just make sure that everything is working all right. Just a minute. Let's undo this. Okay, so let's click on the marks and make it into a bar. Perfect. So that's what we wanted to see. If you want to see the numbers, we can put the sum in label as well. And if I increase the size a little bit, now we can see the difference, which is nothing but the difference in the number of months. That means for EE3152, between the first and the last login, there have been 42 months. So I hope you can see where we are headed with this. If we know that the difference is 42 months, and if I also know the number of total logins, I can divide the total number of months by the number of logins to find the average login. So let's create another sheet. In this, we will keep the user ID and the login date. Let us make this the day and discrete. The total number of months per user is coming in my columns, and we also want to keep the number of logins per user. So this is something we knew we need to calculate, but simple enough. Let's create a calculated field. This would be the number of logins per user. Very simple. It is for each user ID, the distinct count of the login date. Once we have done this, the number of logins can come in columns as well. And now we want to make sure that both of these are bars. Wonderful. So let's understand what is it that we are looking at. For EE3152, the user ID, we can see that 8th June 2011, 8th August 2013, these are the login dates. What is this showing me? This 42. This means the number of months that the user has been active. And what is this number? The number 6, it means the total number of logins that EE3152 has done. Fair enough. Now we need to find the login frequency. So please click on analysis and create calculated field. This would be the login frequency, and very simple. My login frequency is going to be the total months that the user is active divided by the number of logins per user. Everything seems okay. And what else do we need to do? Let me think. So we also need to find the login frequency as a rounded number so that we don't get decimals. All right. So let's just make sure to create another calculated field in which we find the login frequency bin, which would be round of my login frequency. Perfect. Now this bin will come in columns, and you notice we get a third column now. Again, let's understand what is happening. Simple enough. 42 months active, 6 number of logins, and 7 is the login frequency. 26 months, 4 logins, 7 is the login frequency. So I hope you're able to see that we are rounding the number, because even though the exact number of logins here is a little lesser than 7, like 7 logins per month would have been 28, that's okay. We are okay with this level of approximation. Let me also go to tooltip and help the user understand what is it that we want to show here. In fact, we don't need to change it. Let's create the final visualization. In the next sheet, we want to, let's say, look at only one market. So let's look at maybe the European Union. Let's keep the frequency bin in columns and the distinct count of the order ID in rows. what do you think is happening? What it is doing is that my login frequency right now is a measure. That's not what we want. So let me do that once again. We want to take the login frequency bin because we have created bins. I want to put it in the dimensions. And now you notice we will get a chart like this. Very cool. Now, how does it work? If you want to understand this number, we also want to look at the percentage. So let me make sure to select this and change the table calculation. So we want to make it the percent of total, and the percent of total will be table across. Just make sure to confirm this. Okay, look at this number, 24.91%. This means that 24.91% of my total users are logging in 5 times per month. Make sense? So let me change the tooltip. This would say that this percentage of users log in these many times per month. 24.91% of users log in 5 times per month. 90.62% of users log in 4 per month. This should be times. Excellent. Once we have done this, we can also improve the way the visualization looks. So we want to find the average frequency for all the users, which means we want to exclude the login frequency bin when taking the average. So let's create a duplicate sheet, and we want to find the average login frequency. So please click on calculated field. Let's call this the average login frequency. And because we want to exclude something, we want to use the exclude level of detail expression. That means we want to exclude the login frequency bin and then find the average of the login frequency. Essentially, what we are saying is that when we will be presenting this, we want to draw a reference line on the horizontal axis. So before we do that, let us make sure the login frequency is continuous as a bar. That is how you will put a reference line. Go to Analytics, select the reference line and put it on the login frequency pane. The value would be the average login frequency, and we also want to show the value, and we will get a line like this. We can also edit it to make sure that the value is shown. Oh, wait a minute. The value is already shown at the bottom, 5.517. Okay. So we are getting there. One more thing we can do now is to do something with the colors. So even though this looks great, we might want to add one more thing, which is to take the difference between the bins and the average and put this on the color, which means please click on calculated field and one final calculation, which is the difference from the average, which is the login frequency bin minus the average login frequency. Let's put this on the color, and now we will get basically different colors. So All the numbers to the left, right? What are these showing us? It is telling us the number of users logging in different times in a month, right? Or rather, on an average, how many times in a month. Let's go to tooltip and make it a little better. So we'll say this is the percent of. Let me just make sure we can insert it directly so we don't have to type it. We will say we want to show the percent of total destined customers of users who are logging in. Then let's insert the login frequency bin times per month. Perfect. Let's also change it to bold. Maybe increase the size a little bit. Make it bold as well. And increase the size a little bit. Perfect. Let's see how the final result looks now. So this is telling us that 5.517 is the average. And if you look at this column, it tells us that 24.91% of users are logging in 5 times per month. 19.62% of users are logging in 4 times per month. And 11.45% users are logging in 7 times per month. So it's an excellent way to see the skew of the data. For example, here we have a left skew where we can see that we have 24, 19 and 10 here. And we have 12, 11 and 6 here. In this example, we will look at proportional brushing. So there are two ways in which we can analyze a data set. If I'm looking at a category, let us say appliances, we want to see what is the proportion of appliances to the total sales, right? And at the same time, I also want to see what is the contribution of the country that I'm looking at versus the sales of the total market or the total world. Let's look at the data set. So we're working on 0, 1, 1, or rather, let's just call it 1, 1. We have a transactional data with us, 11,000 records. We have category, city, country, ID, name, the market, order date, order ID, product details, and we have a lot of other fields. We are only concerned with the sales and the country and the subcategory. Let's go to Tableau and connect to 11th data. The first thing we want to do is to show all our subcategories. So let me select that. And we also want to show the sales value. And let's give the sales in columns. So we see that chairs is 512,000 and labels, which is the smallest, is 22,000. We also want to look at the total sales by the subcategory, which is a calculation we want. So analysis, create calculated field. And the calculation that we want to do here is total sales by subcategory. This would be a level of detail which is fixed subcategory and the sum of sales. Now right now there would be no difference. When I put the total sales in the column, you notice we get the exact same result because we are looking at all of the subcategories, right? That is why what we want to do is to create a dual axis. So right click and dual axis, and let's convert this into a bar. So what's happening now is that we have two layers with us. One layer is showing us the total sales, the other is showing us the level of detail that we calculated, which is what you can see here on the right. So blue and orange color. So let's change the color. Let's change this to any color. Let's make it blue. And let's make sure we have selected the total sales, and we want to change the color to maybe a gray. Now we can see the total sales, which is the level of detail, but we can't see the actual sales. That's okay. We know that that value is at the back. But it is always better to keep the level of detail expression in the front. So just make sure to swap these like this. So now you notice the sales is in the front and the total sales is at the back. Okay. The next thing we want to do is to create a sheet and again put all our subcategory. And here we want to look at the percent of total. So we will create another calculation, analysis, create calculated field. And this is my percent of total, which is the sum of sales divided by the average of total sales by subcategory. All right. This percent of total will come in the columns. So we can see the percentages here. Right now, everything is 100%. Let's just make sure to go to format and convert everything into a percentage. Okay, so that's all right. Let's put it in the label as well so we can see. Again, we want to convert this into a percentage and a percentage. Right, so we can see all the 17 subcategories and we can see the percentage value. All right. The final step is for us to make a map. This is simple enough. Double click on country and look at the sales value as the color, and we get a map like this. Finally, let's create a dashboard. In this, we want to first keep the map at the top, below which we'll keep both our bar charts, the first one and the second one. We don't really need to show the axis two times, so let me just remove the header so we can only see one axis like this. So this looks clean. Let's also hide the title. We don't need that. And hide the title here as well. Wonderful. And let's see what else do we want to do. Yeah, I think this seems okay. Let's just make sure to go back to the first sheet and sort it alphabetically from accessories to tables so that sheet 1 and sheet 2 are synchronized with each other. As you can see, we have the same 17 subcategories coming two times. We don't need that. So we can remove the header from one so that we only have the subcategories coming one single time, which is on the left. Let's go full screen. And no, before we do that, let's select the map and select use as filter so that when I select a country on the map, both the bar charts should change automatically. So let's see what happens now. So what we're going to do is to select any country, for example, India, and you notice a couple of things are happening. In the second bar chart, it is telling us that if we look at accessories, 18.07%. What does it mean? That India is generating 18.07% of total accessories sales. And Why are there two numbers coming here? So I know this is not what we want. So let's just go back to the first sheet. And if you notice, we're getting two numbers here. So just make sure to remove the number from one of these. In fact, we don't need either of the numbers. So let's remove the numbers from both of them. So I remove the sales value and the sales value. And we just want to show an interesting tooltip. So let's go to our tooltip and we want to make a change here. We want to say that. Let's see. So we want to say that the subcategory and the total sales amount. So that's what we're able to see, subcategory, and let's not call it total sales, such a complicated one. Let's just call it total sales. Okay, that's all right. And let's go to our dashboard. And now you notice we don't have the numbers here. We can see 33,000 and 186. Do you see this? What is 33,000? 33,000 means that in accessories, 33,000 is what is being sold in India. And what is 186? That is the total sales for the entire world. Watch this. For the entire world, it is 186, but when I click on India, it is 33. Again, one more time. When I select Australia, we notice we get 15 and 63. Do you notice that there is something wrong with the numbers? It is not looking correct. Like in India, this is 186 and this is 33, but you would notice that they're not to scale. Like it is almost 90% filled. So let's go back and see why this is happening. So let's remove the country action for a moment and let me edit my axis. So this is the axis which is the x-axis, but we also want to look at the second x-axis. So let's just put the total sales. We already have the total sales. Let's select the sales one more time and put it in columns. In fact, you know what? I'll just do it once again so that everything works properly. Let's put our sales value and our total sales value. And we also want to select, let's see, our subcategory. Let's sort it. We don't need the title. Okay. Now we want to make a dual axis, which is dual axis, and make sure to synchronize both the axes, which is right click and synchronize axis. Now let's convert it into a bar and we can see all the 17 subcategories here. And now we can hide the header from the x-axis at the top. Let's see the dashboard now. So when I select India, you notice now it is looking perfect. This is 33, the total is 186, right? 35, 307. When I select Australia, we have 55, 186, 94, 307. So obviously the total for the entire country will never change, as in the entire world will never change, but the total for the specific country that we're looking at will keep on changing. So if you notice, whichever country I select, the width or rather the length of the bar never changes. All that changes is the blue one, which is telling me what is the contribution of that country. For example, if we select China, we can see that China is 106 and the total for bookcases is 504. And what is this number to the right? It is telling me it is 21% of the sales, right? Which means that for the specific bookcases, everyone, so we're looking at China here. And if I'm looking at bookcases, it is telling me that for the specific subcategory, which is bookcases, 21%, that means 21% of the total bookcases sales in Asia Pacific is coming from China. But I think we should show this in the tooltip so that it looks more meaningful to the user. So let's just make sure to go back to sheet number 2. And on the tooltip, we will say here that Let's do it from the beginning. So we'll say that first the country, which is my, okay, I can't find my country here, but that's okay. We can simply write the country, which is an attribute and my country. Okay, which generates the percent of total of total. Now we want to have the subcategory sales in our market, like this. So that looks good. Let's see the result. So right now you notice it tells us, okay, the country is not working. I think I forgot a parenthesis here. Let's just quickly check. Yeah, so this should be a parenthesis and then a closing sign. Perfect. So it tells me, oh, it's still not working. Let's see, just a moment, everyone. I'm not really sure why it's not working. Never mind. Let's try to put the country in detail, and in tooltip, maybe we can just select it directly now. So let's insert our country. Okay, so we don't really need the ATTR. We can just put the country directly. All right, let's see the result now. So you notice it says China generates 21% of total bookcases sales in the market that we are looking at. So like we did earlier, let's put the market in detail, and in our tooltip, let's remove this one and let's insert our market like this. All right, let's see the final dashboard. So everything looks great. We have different countries that we are plotting. Let's zoom in and let's look at anyone. Let's say we want to look at Indonesia. So what does it do? It tells us that in Indonesia, we have accessories, which is 12,000. Total accessories for the entire world is 186,000. And Indonesia is generating 6.64% of the total accessories in Asia Pacific. All right. Now there is a small problem, which is that we are getting these breaks. Let's make sure we fix that. Oh, so we are getting the details here, which we clearly don't want. So let me remove the country and the market from the detail. But if we do that, then we will not get the tooltip. Okay, that's very peculiar. Let me see how we can fix that. So let me just think about it. Why don't we try to put our market in the tooltip directly? Yeah, I think that will work. And let's also put our country in the tooltip. All right, so we will say here that the country, perfect, is generating of total subcategory sales in our market. Perfect. So this hopefully should give us the correct result. Yeah. So now we can select Indonesia and it tells us 12,000, 186,000 and 6.64%. 59,000, 504,000 and 11.85%. So this is what we term as proportional brushing, which means that we are able to look at any country and we are able to see different layers of analysis. One is the actual value, which is the contribution of that country to that subcategory versus the total sales for the entire world, and that same value as a percentage as well.